We have another question over here, question 8. The question says that determine f prime of x from the first principles if f of x equal to 4x squared. Well, I'm going to write here 8.1. We're looking for f prime of x from the first principle, okay? While f of x is given by 4x squared. Now, first of all, the derivative from the first principle is given by, I'm going to write here f prime of x equal to the limit of the function of f of x plus h minus f of x all over h here, while h approaches 0. Now, over here, I'm going to write like f of x. Okay, I'm going to write here f of x plus h. Okay, let's first work out f of x plus h, and then we're going to subtract that from f of x and then divide by h and then work out the limits of all this. So now f of x plus h here, this one simply means wherever we have x, we're going to substitute by x plus h. Initially, the function was given by 4x squared. F of x was 4x squared. Now f of x plus h will be 4, okay, open brackets like that, close brackets. So instead of me writing x, I am going to write x plus h, okay? And then this will be then 4 x plus h times x plus h. Note that it is important to do not write here x squared plus h squared. So careful, it's wrong to do so. Okay, we don't x plus h to the power of 2 is not x squared plus h squared. We must extend it this way, and then this will be then and so we'll do 4. Okay, let's first work out the brackets x times x and then x times h and then h times x and then h times h there, and this will be like 4 open brackets. X times x makes x squared, x times h makes xh, h times x makes xh, and then h times h makes h squared. Now this will be we can times, okay, let's first simplify what is in the brackets. That makes like x squared. We have like terms, xh and xh are like terms, so this 2 will make like positive 2xh and then plus h squared, close brackets, and then we can times by 4. That makes like 4x squared plus 8xh plus h, excuse me, plus 4 8xh plus 4h squared. All this is just f of x plus h. Now initially f of x was given, okay, this was equal to 4x squared. Now we can work out the difference of the numerator here, okay, f of x plus h minus f of x. So let's do, if we, excuse me, if we minus these 2, we will get like 4x squared minus 4x squared can be simplified out, and then we can complete the missing here by 0, the missing side here by 0. Now we have like now 8xh plus minus 0 will be just 8xh, and then 4h squared minus 0. I say minus because I'm minusing the 2 functions, so it's gonna be, it's like here I did 4x squared minus 4x squared, it's 0, okay, and then I can take over there I take 8xh minus 0, 8xh, 4h squared minus 0 is just 4h squared. So the difference, this is the difference between f of x plus h and f of x. So basically I work out the numerator here. Now when I take this numerator divide by h, so let's do it here. we already have like f of x plus h minus f of x, and then we got this is equal to xh, 8xh plus 4h squared. Now we're going to divide both sides. We divide here by h, and we will divide there also by h. Now by doing so, this is what you get. Okay, how can you do that? We notice that over here there's h and then there's h there, so we can take h as a common factor. So h can be not just h, but we can just take 4h as a common factor. Okay, and then this will be there's going to be like 2x plus h over h, and then we can simplify these two, and then we have left with then 4 open brackets 2x plus h, and then so this simply means f of x plus h minus f of x, okay, equals to over h equal to 4 open bracket 2x plus h over h. Okay, then we can introduce the limit both sides of the equation. So I can put limits here to because we did work out the numerator and the whole fraction. Now we need to introduce the limits where h approaches 0. Okay, let's do. If I put the limits h approaching 0, the function will be then f of x plus h minus f of x all over h, okay, equal to limit also. Well, I shouldn't put h, this one, this line, this is not, yeah. Okay, and then this might be the limit also of h approaching 0 of what? 4 open bracket 2x plus h. Now, to work out this part, it simply means wherever where we have h, we're gonna substitute h by 0. Okay, we're gonna sub in here by 0, and then we won't need to write the limit again. So we just want to say equal to 4 2x plus 0 for x there, and then this will be 8x. Therefore, the derivative f prime of x from the first principle is just equal to 8x. And then the next question is question 8.2. Let's see. Question 8.2.1 says that the derivative of this function, the function is inside the brackets here with respect to x. Okay, let me move this over. I'm gonna write here 8.2.1, and then the function, it was given that dx of x squared minus 2x minus 3 over x plus 1. So now looking for the derivative, okay? So what is this equal to? Let's first consider what is in the bracket here, okay? The function here. The function itself is x squared minus 2x minus 3 all over x plus 1. Okay, situations like this, we will see if we can simplify the fraction, okay, or simplify the function, then see if we can differentiate it. Now let's see, x squared minus 2x minus 3, I can put x in the bracket like that, okay, x in the bracket like that. We do that when the leading coefficient is just 1, okay, when it's 1, put x in the bracket like that, as I did. and then over x plus 1. Now, what are the values I'm going to place in? I'm going to consider the last term, the constant term, which is -3, okay? I'm going to write here -3. Now, the factors of 3 are like 1 and 3. Now, when I say to myself, how can I get a sum of -2, okay, from the factors of -3? This is possible if it's +1 and -3, because +1 and -3 makes -2, okay, and then +1 and -3 equal to -3, okay. +1 times -3 makes -3, so we can place in the +1 and then -3. Now, what we can do, we can simplify this fraction, and then we have left with x minus 3. So the fraction here can be, this whole fraction can be simplified. Okay, we got x minus 3. Then we can differentiate it. Okay, so we can do the derivative of with respect to x of x minus 3. This simply means the derivative of x minus the derivative of the number 3. Okay, now the derivative formula is like a x to the power of n. Okay, derivative, this is n times a times x to the power of n minus 1. Okay, now this will be equal to, you know, over here the exponent is 1. If you don't see any exponent, it's 1, and if you don't see any coefficient, it's also 1. So applying this formula is like, you have like 1 times x to the power of 1 minus 1, okay? Because n, the exponent n get down, so the exponent 1 get down to 1 there, times a was 1 also, so there were another 1 there, okay? The coefficient of x is 1, and then x to the power of 1 minus 1, n minus 1, so 1 minus 1. And then the derivative of any constants is just equal to 0. So in this case, the derivative of 3 is just equal to 0. Then over here we have like 1 x to the power of 0, and then that's equal to, you know, 1. So 1 times 1, because any number raised to the power of 0 is 1. Therefore, the derivative of, with respect to x, of x squared minus 2x minus 3 all over x plus 1 is just equal to 1, because you're like 1 times 1 there is 1. Okay. The following question is question 8.2.2. It's over here. Um, 8.2.2, the question says that we need to determine the second derivative of f of x if f of x is equal to square root of x. So I'm going to read it over here. (8.2.2) f second derivative of x is what we are looking for. Okay, if f of x equal to square root of x. Now the best way of solving this is like, instead of me writing like, let's first consider f of x is equal to square root of x. Instead of me writing like that, I prefer to write this in exponential form. Okay, you know, we have like square root of the nth root of a to the m is equal to a to the m over n. Okay, so this will be written as f of x equal to x to the power. Okay, when we don't see any indices on the roots, it means the index is 2. Okay, and then x is like x to the power of 1. Therefore, we can write x to the power of a half. So we have this, and then we can apply now the law of, the rule for differentiation. So if you have like a x to the power of n, okay, derivative, this is equal to n times a times x to the n minus 1. Now over here, a is just 1, okay, and then n is a half. So the derivative f prime of x will be equal to 1 times, okay, a half first times 1 times x to the power of a half minus 1. And then let's simplify this. This simply means that f prime of x will be equal to a half x to the power of negative a half. This is the first derivative, but now we're looking for the second derivative, okay? We're gonna apply the same rule over on this again. This is gonna be like the second derivative then will be n, which is the exponent. Over here, n is negative a half, and then a is a half, okay, that's e. So this will be negative a half n times a, which is a half, times x, okay, to the power of n, which is negative a half, minus 1. And then this will be the second derivative of x will be equal to negative a half times a half makes negative a quarter x, and then negative a half minus 1 is negative 3/2. So f second x is equal to we can write it like a negative, and then over we can transform it. Okay, you know, when we have a negative exponent, we can write all this at the denominator with a positive exponent. We already have like 4 at the denominator, so we can write 4 x to the power of 3/2 under 1 like that, and then applying the same rule we had here, but this time from right to left. From right to left, remember those rules are useful from left to right as well as from right to left. So this will be equal to the second derivative. This will be equal to 4. Then this will be square root. The denominator is 2, so square root of x to the power of 3. Okay, negative sign there, all under 1. So this is the final. So you can write it. You can write it this way as we did here, or we can write it this way, or we can also write it that other way. So it doesn't matter how you can write it. Okay, thank you.